We are starting our final our final lesson in chapter 1, and so that final one is 1.6, and it's kind of a it's a pretty chill section. So meaning that it's not going to go too in depth. Just kind of give you a brief intro and overview of what a polygon is. So I would say the most important sections up to this point has probably definitely been 1.5, 1.4, some of those. This one is not as important, but there are a few nuggets that we can pick out from here. Okay, now in every plane, right? A plane is like a flat surface that goes on forever. Right? So, imagine you're in the desert and you just look around and all you see is just flat surface. That's what a plane is, okay? Now, let's say you were to write in the ground of the desert and you were to draw yourself any kind of shape that you wanted, right? So let's say you drew yourself a star, right? Let's say you drew yourself a square or a triangle. Right, so anything that can be drawn, a shape that's closed in this way, like it's closed, the sides don't open up. But anything that's closed that can be drawn like that, this is called a polygon. Okay, so if we were to give a formal definition for polygon, it would go something like this. So a polygon is a closed plane figure. Okay, that has the following properties. With the following properties. So the first property that it has to have is this. 3 or more line segments. Called sides. So notice if it's a segment, it has to be straight, right? So for example, if I were to draw something like this, whatever this is, we would say this is not a polygon. Okay, because it doesn't have straight line segments for its sides. The second property that it has to have is this. Okay, basically the sides intersect. So 2 sides intersect in a point. Okay, so something like this. And then you can see here, 2 sides intersect in a point, and 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 a point like that. And each one of these is called a vertex. So this shape has 6 vertices, okay? All right, so that is an intro to polygons. And I guess if I were to just break down the root here a little bit, you have poly, so words like polytheistic, right? Belief in many gods. Even in algebra, I don't know if you saw polynomial, right? It's many, right? It's many terms, monomial, polynomial. So polygon is also many. Okay, and then gon, like sides, many sides. Okay, so that would be a polygon. Okay. Now, a polygon you can classify in 2 ways. So it can either be convex or concave. So your convex, I would say, is more like your normal polygons, and then your concave, I would say, are like your abnormal polygons. So something typical, like, let's say, like a triangle. Okay, or let's say a pentagon, 5-sided figure. or let's say, you know, like a trapezoid. Okay, these are all examples of convex polygons. Now, why are they convex? Because here's what happens. Notice, when I trace my sides like this, I want you to notice that none of the sides end up inside the triangle. Do you see that? So they all stay outside. And these are why they're called convex. And so maybe you're wondering, okay, what I see what you're saying, but what would be an example of a concave polygon? Well, let's say we drew something like this. Right? Let's say we drew a cross. So it looks like a polygon because according to our definition, right, it has at least 3 or more segments called sides, and then the 2 sides intersect in a point. So we see that happening here, right? We see all the straight sides, we see all of them intersecting in a point, and so that appears to be the case, but this one we would actually consider to be concave. And the reason why that happens is because when we trace each segment, look at what happens. Do you see that? It cuts into, and not so much on the outside, but really this one and this one and this one and this one. They cut inside of the polygon. And when that happens, it is called concave. Okay? So if I can just give another example here, just one more. So let's say we had something like this, right? It kind of looks like a house or something. And we might think, okay, this looks like a polygon because it has straight sides. They all meet in a point. They 2 sides meet in a point. But however, when I extend these guys out, check out what happens, right? Right here and right here, they intersect, or the sides go into the interior of the polygon, so it's called concave. Okay? All right. Now, to name a polygon, look at the number of sides. Look at the number of sides. So the minimum is a 3-sided. Then we have a 4-sided, and then a 5, 6, 7, 8, 9, 10, 12. And then we might even have like 50 sides. So these are the number of sides, okay? So 3 sides, 4 sides, 5, 6, 7. And all of these guys, based on the number of sides, they have a certain name. So, for example, a 3-sided figure we would draw like this. A 4-sided figure we might draw like that. A 5-sided figure we would draw like this. And then so on and so forth. And so you can kind of explore. And then the 7th is a little tricky, but you can, eventually you'll be able to get it. 8 would, be something like this. Okay, et cetera, et cetera, et cetera. Okay. Now, these all have special names, and it's based on the root. So, 3. Like when you ride a tricycle, right? So this is called a triangle. 4-sided would be called a quadrilateral. And then you might think, wait, what about squares? What about rectangles? What about all of those? So they all fall under this umbrella of quadrilateral. So quadrilateral is like the entire human species. And then if you have someone from one country, you would call them, a Korean or like an American or like a Canadian, like that. So that's how it works. Quadrilateral is the big umbrella term for 4-sided figures. And then under there, you can put in square, rectangle, so on and so forth. And so 5-sided is called a pentagon. Okay, and you might know that from our landmark in our country, right? A 6-sided would be called a hexagon, and then a heptagon for 7, and then an octagon for 8, Oops, I think I made a typo there. Octagon. And then a 9-sided figure would be called a nonagon. Nonagon. And then a 10-sided figure would be called a decagon. A 12-sided figure would be called a dodecagon. And then an n-sided figure would be called an n-gon. So, for example, a 50-sided figure would be called a 50-gon, right? So, it's kind of interesting. So, hex, hepta, octa, non, nona, and deca, dodecagon. Okay? Alrighty. And then just the last thing is to classify each of these angles. Classify each of these polygons. So, just one way we can classify them. Oops. So the first way is to say that they are equilateral. So let's write all three down, and then we'll come back and visit each of them. The second type is called an equiangular polygon. An equiangular polygon. And then the final type is called a regular polygon. Okay, so I want you to pay attention to the root word again. So for this one, it's equa, and then for this one, it's equal. And then to even take it a little bit further, it's angular, and then here it's lateral, right? So equa means same, and then lateral means one thing, and then angular means another. And so I don't know if you can kind of see it, but equilateral means equal sides. Equiangular means equal angles. Okay, and then a regular polygon means both. So both equilateral and equiangular. So just for example, to use, let's say, quadrilaterals. When quadrilaterals are, quadrilaterals, first of all, are four-sided. And there's probably a bunch of different types of equilateral quadrilaterals that you can think of. But one that comes to mind for me is something called a rhombus. Okay, now a rhombus has four sides that are the same. Okay, so for example, 5 centimeters, 5 centimeters, 5 centimeters, and 5 centimeters. However, notice their angles are different. So these two are the same, and these two are the same, but not all four angles are the same. Here's an example of an equilateral polygon. In the same way, an equiangular quadrilateral. So I think of something like this. Okay, and so when we trace it like this, remember, this symbol in the corner means what? It means right angle, right? 90 degrees. And so we got 4 of them. And so it's all the same, but in this case with the rectangle, notice not all the sides are the same. Okay, so it's just the angles that are the same. And then finally, for regular, when we put all these guys together, right, we end up having a really nice shape. So for example, and so this is called a square. And a square has equal sides and it has equal angles. Okay, and so that is pretty much it for section 1.